Hello, fourth grade, and welcome to Lesson 2 of Module 6 on natural disasters or natural hazards. This lesson, we're going to focus on tsunamis and floods. So let's go ahead and get started. We're going to open up our first pages in our workbook. We're going to read about preparing for natural hazards. You'll read through the scenario on this page, decide which one of the friends you agree with the most, and then fill in your answer using complete sentences on the lines below. Remember to pay attention to your capitalization and your spelling, and make sure that your writing is neat and clear. Next, we're going to watch a video of a river. We're going to write down at least 3 questions that we have, and then answer questions about the STEM career connection, about the emergency management specialist. Let's go ahead and pull up that video and watch it together. All right, think about what you saw here in the video. I can go back and play it for you once more. Pay attention to what's going on as the river is filling up, what's going on to the surrounding areas. Pay attention to how they're measuring the height, how many feet it is over several days, what's going on to the river and the land around it. All right, once we're done with that, you're going to write down at least 3 questions that you have. Read the STEM career connection about the emergency management specialist, and then answer the questions on the following page. What questions do you have about the emergency management specialist journal entry? In what ways can an emergency management specialist help people? And then answer our essential question, how can people prepare for floods? Once you're done with that, we're going to go over our new vocabulary words for this lesson. So again, for this lesson, we only have 3 words. We have the words tsunami, flood, and storm surge. Let's go ahead and review those vocabulary words together before we get into the rest of our lesson. So a tsunami is a huge wave that's caused by an earthquake that happens under the ocean. Because there's so much vibration of the land on the ocean floor, it causes these really gigantic waves that are called tsunamis. A flood is a flow of water over the land that's usually dry. So an area of land that isn't usually covered by water is all of a sudden covered by water. This can be due to a tsunami. This can be due to heavy rainfall. And then we have the words storm surge. A storm surge is an abnormal rise of ocean water that's caused by a storm over and above the normal tides. So storm surge is when the ocean level increases more than it's supposed to, and it's usually caused by a storm. That's where the term storm surge comes from. Next, we're going to watch a video titled Hurricanes, Tsunamis, and Floods on how these natural disasters affect people, and then we're going to answer the questions. What part of hurricanes causes damage? What causes damage in a tsunami? What can cause flooding? What do these 3 types of natural hazards have in common? Which natural hazard would be easiest to prepare for? Explain your choice using what you've learned so far. So I'm going to leave our questions up here on the screen and jump back so that I can put our video. Think about those questions and have those questions open while you watch so that you can fill in the answers as you go.
Weather can be pleasant and not so pleasant. And severe weather can cause damage. Take a look at this radar. It's showing that a hurricane has made landfall. Wow, look at how strong this hurricane is. Hurricanes have very high wind speeds that can cause a lot of damage to property and nature. Now let's look at the damage a tsunami can cause. During a tsunami, huge waves crash to the shore and can cause large amounts of damage, sometimes destroying everything in their path. Next, let's see what an earthquake can do. Look at all of the damage that can be caused from the ground shaking. Have you ever felt an earthquake? Heavy rainfall can cause flooding. Did you know a flood could cause so much damage? What types of damage have you seen that was caused by severe weather?
All right, let's go ahead and head back to our questions. What part of hurricanes cause the damage? What causes damage in a tsunami? What causes flooding? What do these three types of hazards have in common, and which one do you think would be the easiest to prepare for? I'm going to play the video through one more time now that you've gotten a chance to listen to it carefully. This time, let's go through and look for the answers. So fill in your answers as we go. Go ahead and pause the video anytime you need to so that you're able to write your answers down before you continue.
Weather can be pleasant and not so pleasant. And severe weather can cause damage. Take a look at this radar. It's showing that a hurricane has made landfall. Wow, look at how strong this hurricane is. Hurricanes have very high wind speeds that can cause a lot of damage to property and nature. Now let's look at the damage a tsunami can cause. During a tsunami, huge waves crash to the shore and can cause large amounts of damage, sometimes destroying everything in their path. Next, let's see what an earthquake can do. Look at all of the damage that can be caused from the ground shaking. Have you ever felt an earthquake? Heavy rainfall can cause flooding. Did you know a flood could cause so much damage? What types of damage have you seen that was caused by severe weather?
All right, let's go ahead and take a look at those questions. So what part of hurricanes cause the damage? Those extreme winds, those high-speed winds are what cause the damage with a hurricane. In a tsunami, the waves are what's causing the damage to the structures on land. What causes flooding is that when water flows over onto dry land, onto areas that are usually dry. All three of these are all damage that can, all three of these natural hazards cause damage and can be related to not just damage on land, but it can cause damage to structures, it can destroy habitat. Flooding, tsunamis, and hurricanes all start over water, or they all also have to do with water, because a hurricane needs to begin over water before it can touch down on land. Now here for number 5, this is up to you. Which one do you think would be easiest to prepare for? Explain your choice using what you've learned. Next, we're going to read the handout titled Understanding and Tracking Natural Hazards. And we're going to answer the questions, where do tropical storms and hurricanes form? When is a tropical storm considered a hurricane? Explain the hurricane classification system. How do scientists track hurricanes? Why are floods so dangerous? And in what situation can a flood be helpful? So for these questions, we're going to go through and we're going to read this handout. Now, particularly for question number 8, you do have several lines in this area, so you do have to write down a detailed explanation of the hurricane classification system. Let's go ahead and begin reading. Understanding and tracking natural hazards. When will the next hazard occur? A tropical storm is a storm with rotating winds and low pressure at its center. The storm forms over warm ocean waters. It is fueled by warm, moist ocean water. Air moves from the center of the storm outward, creating winds. As the winds get stronger, the storm grows. Tropical storms most commonly affect regions along the Atlantic Ocean and the Gulf of Mexico. Scientists classify tropical storms based on wind strength. A tropical depression is the seed of a tropical storm. It is a storm with wind speeds less than 38 miles per hour. As the wind speeds increase, the tropical depression becomes classified as a tropical storm. A tropical storm has wind speeds between 39 and 73 miles per hour. Once the wind speed increases to over 73 miles per hour, the tropical storm becomes a hurricane. Scientists classify hurricanes into 5 categories based on wind speed. So a Category 1 hurricane has wind speeds that are 74 to 95 miles per hour. Category 2 is 96 to 110 miles per hour. Category 3 has 111 to 129 miles per hour wind speeds. Category 4 is 130 to 156 miles per hour. And then a Category 5 is anything above 157 miles per hour. Hurricanes are dangerous storms which can cause a lot of damage. They bring high wind and heavy rain to an area. The natural hazards can cause storm surge, which is an abnormal rise of ocean water that's generated or caused by a storm over and above the normal tides. In order to protect people, scientists use different methods to track these storms. They gather information using satellite images. They also use radar and direct measurements from airplanes. Radar is a tool that allows scientists to gather information about the wind, precipitation, and storm movement. With this information, scientists can plot the location of the wind of the storm. Because the storms are fueled by warm water, scientists also track ocean conditions. They use this information to determine if the storm will get stronger. With all these facts, they map the possible paths the storm might follow. They use this information to warn people in the path of the storm of the danger. Although high winds and rain may affect coastal areas, flooding can happen farther inland because of the large amounts of rain brought by a hurricane. To warn people, local governments gather as many facts as possible. As the storm approaches, scientists make their best predictions of the storm's path. Using this information, local and federal government agencies advise citizens, organize evacuations, and begin to prepare for the storm. Flooding. A flood is the submerging of normally dry land by water. So that means the regularly dry land is now underwater. Some floods can happen very slowly over time, and some can happen quickly in just a few minutes. Floods can be confined to a small area of land, or the flood can be a very large disaster impacting an entire river basin or region. There are many reasons floods occur, including overflowing rivers, coastal storms, excess rainfall, or by a major failure of structures like dams. River flooding is the most common type of flood event. If the amount of water flowing down the river exceeds the capacity of the river channel, the flooding of the surrounding area can occur. Most rivers have a floodplain, an area on both sides of the river that can accommodate floodwaters. When people build houses on the floodplain, they put themselves in danger from flooding. Flash floods are another type of flooding. They can occur very quickly, sometimes without any warning. Flash floods happen when a blockage in the river, such as a landslide, glacier, or dam, gives way and releases a huge amount of water all at once. Aerial flooding happens when the soil becomes saturated with rainfall, and additional rainfall cannot run off as quickly as the accumulation of water. This can also happen when the ground is frozen or on asphalt or concrete paving. Many cities and towns are located on the coast. Coastal flooding is caused by high sea tidal surges and waves. These large waves and surges may be caused by tsunamis, hurricanes, or tropical storms. Flood events can be major natural disasters, causing loss of life and damage to land and property. Floods can damage buildings, bridges, roads, and dams. Cars and houses can be damaged or even completely taken away by the waters. Floods can destroy sewage systems and pollute water supplies. Floods aren't always bad. Natural flooding in deltas and river plains are essential for farming in many areas of the world. Floodwaters bring nutrient-rich silt nutrient-rich silt deposits that create fertile soil. All right, let's go back and take a look at our reading. Now, I know we covered a lot of material here. Where do tropical storms and hurricanes form? We're going to find out way at the very beginning of our reading. So the storm forms over warm ocean waters. Next, when is a tropical storm considered a hurricane? That information is here in the second paragraph. You can read through it one more time to figure out what does the wind speed have to be for it to become classified as a hurricane. Explain the hurricane classification system. That's right here on the side. Explain what it means. Next, how do scientists track hurricanes? That information is going to be here in our next paragraph right underneath where it says the hurricane categories. Why are floods dangerous, and in what situation can a flood be helpful? That information is here on the following pages. So why is it dangerous, and when can it be helpful? So take a look at the information on those last two pages, and you'll find the answers to all of the questions that we went over. Next, we're going to read another handout called Tsunami. What events can cause a tsunami? What happens when a tsunami hits the shore? What should people do if there is a tsunami warning? What areas are in danger from tsunamis? And how do scientists know when a tsunami is coming? Let's go back to the beginning of this page and take a look at our next handout titled Tsunami. What are tsunamis and how do they change the Earth's surface? December 26, 2004. It was early morning on December 26, 2004. Along the shore of the Indian Ocean, in countries such as India, Indonesia, and Sri Lanka, fishers were getting their boats and nets all ready for a day of work. In Thailand, people on vacation were sunbathing. Shopkeepers were opening their doors for business. It was a beautiful day with hardly a cloud in the sky. Meanwhile, 241 kilometers or 150 miles off the coast of the island of Sumatra in Indonesia, something changed. Here, two of Earth's tectonic plates moved towards each other. One plate usually slides slowly under the other and sometimes gets stuck. Suddenly, the plates became unstuck and slid quickly. The plates moved only about 20 meters, 65 feet. Yet that movement caused the biggest earthquake on the planet in more than 40 years. It also caused a deadly tsunami. Earthquakes under the sea. The earthquake on December 26, 2004 occurred deep under the ocean. It happened when rocks suddenly moved along a crack called a fault. The fault was 1,200 kilometers or 740 miles long. About 241 kilometers or 150 miles away, people on Sumatra felt the ground shake for 8 minutes. Then the shaking stopped. People thought their troubles were over. They were wrong. Movement along the fault pushed the ocean floor, which pushed the ocean above it. The water started to move away very quickly. It spread out in every direction. On the surface of the ocean, there was hardly any change. People in ships right on top of the moving water didn't notice anything. In Hawaii, scientists at the Pacific Tsunami Warning Center learned about the earthquake. About an hour later, they noticed something else. It made them think a tsunami, a giant wave, might be on the move. But by then it was too late. Waves 20 meters or 65 feet high hit the coast of Sumatra in Indonesia. Trees were ripped from the ground. Big ships were tossed around. Some ended up in the forest. The city of Banda Aceh was destroyed. In just 15 minutes, the waves had killed more than 200,000 people. So here we can see the plate movement. Now, because it moved so quickly, it pushed up the ocean water that created these huge waves that went out in all directions. Here is a town on the coast of Sumatra before the tsunami, and this is what it looked like after the tsunami hit. The tsunami moved toward Thailand. There, a herd of elephants began behaving strangely. They stamped the ground and tugged their chains. Finally, they broke away and ran to the hills. The elephants sensed that something strange was about to happen. Special bones in their feet helped them feel the ground shake. At the beach, tourists were enjoying the sun. Then they noticed the water suddenly moved away from the shore, leaving fish stranded. Some people went down to help the fish. That's when a huge wave crashed down on the beach. It was 9 meters or 30 feet high. At least 5,000 people were killed and 3,000 people were missing. The people on the beaches of Sri Lanka also had no warning. 6 giant waves smashed the shore and rushed inland. Whole towns were destroyed. More than 4,000 people died. The waves were weaker by the time it hit India, the Maldives, Somalia, and Kenya. Yet, it was still strong enough to kill. In India, 10,000 people died. In Somalia, 300 people were killed. Kenya reported 1 death. The waves traveled very far. It reached countries more than 8,000 kilometers or 5,000 miles from where it began. Finally, the wave had used up all its energy. The tsunami was finished. By that time, almost 300,000 people were dead. Thousands more were missing. What is a tsunami? The word tsunami comes from 2 Japanese words. Tsu means harbor, and name means wave. Some people call tsunamis tidal waves. Even so, tsunamis really have nothing to do with tides. Tsunamis take place when a large amount of ocean water is suddenly moved aside. Once a tsunami is formed, it cannot stop until the energy is used up. The energy of a tsunami depends on the amount of water that's moved. Even a small tsunami can cause a great deal of damage. In 2011, a tsunami struck Japan. It moved a boat into this building. Earthquakes and tsunamis. What can move so much water? Underwater earthquakes are the most common cause of tsunamis. Faults form in Earth's crust as tectonic plates move and get pushed and pulled. The rocks on either side of a fault can move. When those rocks move suddenly, an earthquake happens. Many earthquakes happen near where 2 tectonic plates meet. Most tsunamis start under the ocean where one tectonic plate slides under the other. Rocks on the ocean floor suddenly move and the earthquake occurs. The ocean floor gets pushed up, which pushes the ocean surface above and starts a tsunami. Waves form and move outward fast. This is what happened in 2004 when a huge earthquake caused a large tsunami. Here in this diagram, you can see the plate boundaries where the tectonic plates meet. Those are outlined in red. Volcanoes and tsunamis. Some tsunamis are formed by volcanoes. When they erupt, melted rock and gas bursts from the ground. This can also start a landslide if the side of the volcano collapses. When these events change the ocean floor and move the water above it, a tsunami can form. The island of Krakatau in Indonesia was a giant volcano that erupted in 1883. When it did, it caused a huge tsunami wave. They were more than 41 meters or 135 feet high. Landslides and tsunamis. Landslides that affect the ocean floor can cause tsunamis. In 1998, a tsunami hit Papua New Guinea. It was started by an underwater landslide caused by an earthquake. Tsunamis made by objects from space. It is possible that an asteroid or a meteorite from space could hit Earth. Oceans cover 70% of Earth's surface. If it fell into the ocean, it would cause a tsunami. Scientists have made a computer simulation of an asteroid hitting an ocean. It shows a tsunami as high as 120 meters or 400 feet high, sweeping onto the Atlantic coast of the United States. This has not happened in recorded history, but there is evidence of asteroids and meteorites having hit Earth in the past. What happens after a tsunami starts? Once a tsunami starts, nothing can stop it. It moves outward in all directions. The deeper the ocean water, the faster the tsunami travels. If the deep Pacific Ocean In the deep Pacific Ocean, tsunamis move about 800 kilometers or 500 miles an hour. These tsunamis can reach distant shores very quickly. Moving in deeper water, a tsunami can cause no harm. In shallow water near land, the waves slow down and grow higher. In the narrow river or harbor, they grow even higher. A wave only 1 meter or 3 feet high in deep water can grow to 10 meters or 33 feet near land. The highest tsunami wave grew to more than 46 meters or 150 feet before it hit a lighthouse off the coast of Alaska. The first wave of a tsunami may cause great damage, yet it's often only one of many waves. Several waves may follow, hitting the beach every 10 to 45 minutes. When a tsunami hits the shore, it rushes up the land, it causes flooding and destroys towns. Very large waves can knock down buildings and bridges, turn over trains, and destroy seawalls. Floating boats and cars can crash onto buildings and power lines. Fires can start and cause much damage. Could a tsunami hit the United States? Tsunamis have hit the United States before. In 1946, a single tsunami hit both Alaska and Hawaii, killing 164 people. In 1960, a tsunami and 11 meters high hit Hawaii and the other islands in the Pacific. More than 1,000 people died. In 1964, a tsunami hit the ocean of Alaska. The tsunami hit the entire coast of Alaska. The same tsunami also hit Oregon and California. A total of 132 people died. Geologists are scientists who study the Earth. They discovered evidence that a large tsunami hit the west coast of the United States about 300 years ago. Some think a tsunami may have helped to wipe out the dinosaurs in North America millions of years ago. Tsunami threat. Volcanoes are found on the Canary Islands in the Atlantic Ocean near Africa. If these volcanoes erupt, a tsunami could move towards the east coast of the United States. Landslides in Nova Scotia and volcanoes erupting in the Caribbean could cause tsunamis that affect the east coast of the United States. The west coast and Hawaii are at much greater risk. Off the coast of Northern California, one tectonic plate slides under another. Sooner or later, these plates will move suddenly. When this happens, it may cause a powerful earthquake, perhaps as large as the one that struck on December 26, 2004. Such an earthquake could start a destructive tsunami. The Alaska earthquake and the tsunami of 1964. The second largest earthquake ever recorded hit Alaska in March 1964. The earthquake caused both large and small tsunamis. These greatly damaged many towns on Alaska's coast and destroyed the state's fishing industry. They also caused great damage in California and Hawaii. Where the plates meet off the west coast of the United States, geologists estimate that one major earthquake occurs about every 400 years. Here we can see fishing boats in Alaska that were thrown hundreds of meters onto land by that 1964 tsunami. The last was about 300 years ago. Yet earthquakes in that area are only one possible source of tsunamis. Earthquakes and volcanoes occur along most of the west coast of North America, from California to Alaska. If an earthquake happens under the ocean in this area, it's likely that a large or small tsunami would occur. What would happen if a tsunami hit the United States? Suppose the moving plates off the coast of Northern California caused an earthquake. The ocean floor could get pushed 6 meters or 20 feet or more. This would cause powerful ocean waves that would rush towards the shore. The first waves would hit towns on the coast in 30 minutes or less. This is fast for a local tsunami. This is too fast for a local tsunami warning system to work. No one would know that the tsunami was on its way. Some cities on the coast would be quickly flooded by the waves. Cities further from the ocean might escape damage, yet buildings could fall. Fires would probably start. Tsunamis in recent history. March 11, 2011. An earthquake in the Pacific Ocean causes tsunami waves up to 38 meters or 120 feet, 28 feet high in Japan. More than 330,000 buildings are damaged and 15,000 people are killed. December 26, 2004. An earthquake in the Indian Ocean produces tsunami waves that damage coastlines in 10 countries. The waves kill more than 280,000 people. July 17, 1998. A tsunami strikes the northern coast of Papua New Guinea, killing 2,000 people. August 16, 1976. A tsunami hits the Philippines, killing 5,000 people. March 28, 1964. An earthquake in Alaska produces a tsunami that hits Alaska, Oregon, and California. During this event, 132 people die. May 22, 1960. A tsunami that is 11 meters or 36 feet high hits Chile, Hawaii, and the Philippines, and Okinawa, Japan. More than 1,000 people die. April 1st, 1946. A tsunami destroys a lighthouse in Alaska. Hours later, it hits Hilo, Hawaii, killing 164 people. Here we have a picture of a town in Japan along the coast right after the March 11, 2011 tsunami. Predicting tsunamis. It's not easy to predict a tsunami since no one really knows when an earthquake will happen or a volcano will erupt. Once such an event happens, it's still not clear if a tsunami will follow. If it does, it's hard to know how big it will be, where it will go, or what damage it will cause. Most tsunamis happen in an area called the Ring of Fire. This area is around the edges of the Pacific Ocean. Here, many tectonic plates meet, and earthquakes and volcanoes are common. Tsunamis have been destroying cities and around the Ring of Fire for thousands of years. So here you can see this is the Ring of Fire. You can see where the dots for earthquakes and where the overlap with where these plate boundaries are. And these are also areas where we have a lot of volcanic activity. In Hawaii, the United Nations established the International Tsunami Information Center. The center helps nations around the Ring of Fire set up tsunami warning systems. It also teaches people about tsunamis and helps scientists to learn more about them. The United States plays a large role in the tsunami research and warning system. The National Oceanic and Atmospheric Administration, or NOAA, manages the International Tsunami Information Center and the National Weather Service. It's up to people working at the National Weather Service and the International Tsunami Information Centers in Hawaii and Alaska to gather the information and decide if a tsunami might be coming. Then they send word to the local communities about the danger of a tsunami. So here we have the warning center in Hawaii using various methods to detect possible tsunamis. The buoy is connected to a pressure recorder on the ocean floor. It measures the weight of the water above it. A big wave is a lot heavier, and the recorder sends a message to the warning center. Tsunami warnings. When tsunami observation stations detect a large earthquake under the ocean, they set off an alarm. Scientists quickly decide whether they think there is a real danger of a tsunami. Then they check to see if the ocean water is moving. If the earthquake takes place near the shore, there might not be enough time to give warning. People in the area may feel an earthquake. People at the beach may see water rush away from the beach. If these things happen, there is no time to lose. People should hurry to high ground at least 30 meters or 100 feet above sea level. If the earthquake happens in the middle of the ocean, there's time to get word to scientists to get word out. Scientists use the National Warning System. It connects national defense, emergency management, and the United States Coast Guard. Each hour, information is updated. Local tsunami warning systems must get word out to people in the area of danger. Warnings are sent to all the people in the area in many different ways. These include warnings on radio, television, and websites, and warnings sent by email, phone calls, and text messages. In many places, sirens go off to let people know that danger is coming. On the lookout. Palmer, Alaska is the home of the National Tsunami Warning Center. Here, scientists watch for signs of tsunamis and warn people about the danger. The National Tsunami Warning Center issues warnings for all of North America on both coasts. It sends out warnings of tsunamis in the Pacific Ocean. It also keeps an eye on possible dangers from volcanoes in the Canary Islands and off the coast of Puerto Rico and the Caribbean islands. Tsunamis can be very dangerous. They move very quickly and pick up and throw cars and boats around as if they were toys. The United States Federal Emergency Management Agency, or FEMA, has information about how to prepare for a tsunami. It also tells people what to do if a tsunami hits. Make plans. Find out if your home is in an area where tsunamis might hit. Know the warning signs. An earthquake could be your first warning. A quick rise or fall of water along the shore is another. Go away from the shore or to a higher place right away. Make a family emergency plan. Decide where to meet. Pick a place away from the shore and high above sea level. Roads may be closed, so pick more than one way to get there. Find out where the nearest shelter is. Prepare an emergency kit to last for 3 days. Include a flashlight, radio, and extra batteries. Include a first aid kit, emergency food, and water. Pack medicines, cash, credit cards, and sturdy shoes. Decide how you will communicate with your family. If family members get separated, have a plan for getting back together. Ask a relative or friend who lives in another state to be the family contact. Make sure everyone in the family knows the person's name, address, and phone number. Make a plan of where to meet. Pick more than one way to get there since roads may be closed. Take action. Listen to the radio or television to get the latest emergency information. Be ready to leave the area if you're told to do so. If you hear an official tsunami warning or see signs of a tsunami, leave right away. Climb to high ground. Stay away from the beach. Never go down the beach to watch a tsunami. If you can see the wave, you may be too close to get away from it. Return home only if officials say that it's safe. Remember that there may be more than one tsunami wave. The next wave may be larger than the first one. All right, now after going through that very long reading on tsunamis, we can go ahead and answer these questions. What events can cause tsunamis? So movement in our tectonic plates, earthquakes, volcanoes, all of those can lead to tsunamis. What happens when a tsunami hits the shore? You can talk about some of the destruction that happens. What should people do if there is a tsunami warning? So the first thing you need to do is get yourself to higher ground. What areas are in danger of tsunamis? So coastal areas, anywhere near water, places that are around the ring of fire are all at high risk for possible tsunamis. How do scientists know when a tsunami is coming? So they look for signs, and we talked about some of them. Go back to your reading to get additional details about earthquakes, about the water rushing away from the shore, any volcanic activity, any movement in the tectonic plates. Those are all warning signs that help them figure out if a tsunami is coming. All right, next we're going to explore the digital interactive historical tsunamis around the world. We're going to answer questions after we finish. So describe the cause, location, and wave height of the March 1964 tsunami. Describe the cause, location, and wave height of the December 2004 tsunami. So let's head over to our digital interactive.
March 28, 1964. Caused by an earthquake with a magnitude of 8.4 and underwater landslides. 1964 Alaska earthquake. Wave heights of 8.2 meters, 27 feet were recorded. March 28, 1964. Caused by an earthquake. March 9, 1957. Caused by an earthquake with a magnitude of 8.3. 1957 Aleutian Island tsunami, Alaska. Wave heights of 16 meters, 52 feet were recorded. April 1, 1946. Caused by an earthquake with a magnitude of 7.8. 1946 Aleutian Island tsunami, Alaska. Wave heights of up to 39.6 meters, 130 feet were recorded. May 22, 1960. Caused by the most powerful earthquake recorded to date with a magnitude of 9.5, Chile. Wave heights of up to 25 meters, 82 feet were recorded. December 26, 2004. Caused by the third largest earthquake recorded to date with a magnitude of 9.2, Indian Ocean. Wave heights of up to 30 meters, 100 feet were recorded. Countries most heavily affected were Indonesia, Sri Lanka, India, and Thailand. March 11, 2011. Caused by the fourth most powerful earthquake recorded to date, with a magnitude of 9.0. Pacific coast of Japan. Wave heights of up to 40.5 meters, 133 feet were recorded. The tsunami traveled 10 kilometers, 6 miles inland in one area of Japan. This tsunami is responsible for the nuclear accidents at the Fukushima Daiichi Nuclear Power Plant, Japan. November 4, 1952. Caused by an earthquake with a magnitude of 9.0, Kamchatka Peninsula. Wave heights of between 15 to 18 meters, 49 to 59 feet were recorded.
All right, let's head back over here. Describe the cause, location, and the wave height of the March 1964 tsunami. So that's going to be, I believe, this first one. Oops. Yes, this is the March 1964 tsunami. So the information is here. And then for our next one, the December 2004 tsunami. Was this one down here. So you can pause the video, copy down that information, and then we're going to move on. Where are future tsunamis likely to happen? Support your answer with evidence. So think about things that we've learned and read so far. Now we've gone through our handouts. And our last one, we're going to read a handout titled Preparing for Natural Hazards. How can monitoring and early warning systems help people prepare for natural hazards? How can buildings be designed to withstand the effects of natural hazards? Number 3, what natural hazard is most likely to be a threat for each city? Write the name of the natural hazard beside the name of the city. If a city has multiple hazards that are likely, then you may list more than one. Use what you've learned about each natural hazard. You'll want to use a map to locate each city to help you determine the threat of each natural hazard. All right, let's go ahead and take a look at our handout and answer these questions and fill in that table. What do you need during a disaster? A natural hazard is an event that occurs and can be dangerous to people and property. It's not always possible to predict when a natural hazard will occur. It's possible to be prepared. Natural hazards do not happen equally across the country. Each region experiences different types of hazards. A volcanic eruption is an outpouring of melted rock, ash, and gases. Volcanic eruptions usually occur at the tectonic plate boundaries. For example, there is a circle of volcanoes that surround the plates in the Pacific Ocean. The region has received the nickname the Ring of Fire. Areas in the Ring of Fire are at risk for volcanic eruptions. An earthquake occurs when rocks rupture along a line of weakness called a fault. The destruction can be enormous. Earthquakes can happen anywhere, but are more commonly found in the western United States. A tsunami is a huge wave caused by an earthquake or under the ocean. Areas along the oceans are at risk for tsunamis, especially along the Pacific Ocean because of the large number of earthquakes that occur in this region. A hurricane is a storm that forms over the ocean and brings destructive winds and rain to the coastal areas. The Gulf and Atlantic coasts of the United States are at most risk for hurricanes. Floods can occur anywhere, but low-lying areas that receive a lot of rain are more at risk. People can prepare for natural hazards for which they are at most risk by developing emergency evacuation plans, shelter plans, and by assessing emergency supply kits. The specific hazard, its severity, and the amount of warning time determine whether people seek shelter or evacuate as a hazard approaches. For example, people may be instructed to evacuate or seek shelter if the event of volcanic eruption, in the event of a volcanic eruption. Earthquakes often occur with little or no warning. People can be prepared by securing objects that might fall and identifying safe spots to use as shelters during earthquakes, such as under a sturdy table. Tsunamis can be predicted by detecting underwater earthquakes. A warning is sent to the areas at risk. People can seek shelter on higher ground away from the shorelines. Hurricanes can be predicted using satellites and other weather forecasting technology. Depending on the size and strength of the hurricane and its path, people may be instructed to evacuate or seek shelter. People should be prepared by having a plan for both. When flood warnings are issued, people should evacuate to higher ground. Locate each of the following locations on a map of the United States. Use a map that shows where bodies of water are, such as lakes, rivers, and oceans. Use what you've learned about natural hazards to determine which hazard or hazards are most likely to affect each location. Record the hazard or hazards in your Be a Scientist notebook. So Minneapolis, Minnesota is at risk for volcanic eruptions, earthquakes, tsunamis, and floods. Phoenix, Arizona is at risk for volcanic eruptions, earthquakes, tsunamis, and floods. Savannah, Georgia is at risk for volcanic eruptions, earthquakes, tsunamis, and floods. Seattle and Tulsa. So these are our options for each one. What you're going to do is decide which one is most likely to hit those areas based on where those different cities are located. So look at where Minneapolis is located and decide which one of those 4 natural hazards are likely to hit that area. The same for Phoenix, Savannah, Seattle, and Tulsa. Decide which one, or if there's multiple ones, are likely to hit those areas. Okay, how can monitoring and early warning systems help people prepare? We read about that earlier in our handout on the first page. Our next question says, how can buildings be designed to withstand the effects of natural hazards? We read about that in a previous handout, about using sturdier building materials, about having things secured so that things are not breaking and falling down. And then for number 3, you're going to decide which of those 4 natural hazards are most likely in these different areas. If there's more than one, you can list more than one. Go ahead and use a map of the United States to help you determine where these areas are located so that you can figure out which natural hazards are most likely to occur. All right, that takes us to the end of this lesson. If you have any questions, let me know. Otherwise, have a wonderful day. Take care. Bye-bye.